So parameters can be especially useful when a child's trying to learn things about language structure that are otherwise hard to learn, maybe because they're really complex or because they appear very infrequently or not at all in the available data, right? So let's talk a little bit more about how that works. It has to do with something called an over hypothesis. And the thing to remember is that we can think of language systems, grammars, the properties you need to learn about your language as collections of these little parameter values, which I've symbolized here with these little dots. And so a grammar, a whole language's system of rules is going to be encoded in this little box, right? So you have different variants of this here. For example, we might have a system with 5 parameters and 2 values each. So we might get 2 to the 5th possibilities, and these are just some of them, right? And so a parameter, right, and its specific value will determine what we predict should be observed in the world in a variety of situations. So this green curve doesn't just tell us about we expect to be this person to be, say, 2 minutes early to class -2, but we in fact don't expect them to be 5 minutes late or even 2 minutes late or really even on time, right? We have certain expectations because of the value of that parameter. So an example linguistic parameter would be something like head directionality, which determines what order we expect the head of the phrase to be with respect to all the rest of the stuff in the phrase. And linguistic parameters like this are supposed to correspond to properties that do vary across human languages. So okay, what's good about this? The good thing is that parameters are meant to connect to multiple structural properties, and this is really helpful for acquisition because you can learn something about that parameter's value by observing many different kinds of things, right? You can learn about this value by observing any of these because this one connects to all of these. So to make that a little bit more explicit, let's assume that there are a number of properties, these guys here, that are connected to parameter p, this guy up here. And that parameter can take one of 2 values, value A or value B. Okay, great. So question, this is what you're trying to learn if this is your setup. Well, what value does P have? Is it A or B? And how could you learn about that? Well, one way is to observe instances of property 3, right? Sorry, we were trying to learn whether property 3, shows behavior A or B, right, which is connected to P. And one way to observe that is to say, well, let's just look for instances of property 3 and let's find out, are they A or B? Maybe they're A, maybe they're B, right? But what if property 3 occurs very rarely or not at all? We might never see any examples of that, but we still want to know about it. Well, again, that's where this connection comes in handy, okay? So because property 3 is connected to P, we can learn the value for property 3 by learning the value of P, okay? Right? That's the point of it. So P, in this case, is connected to properties 1 and properties 2. So what does that mean? Well, that means that we can learn the value of B, A or B, from either of these two, from property 1 or property 2. We just need to see like any of these to learn what that parameter value is. So let's say that we see an example of property 1, which has value A. Well, then we know that P has value A because P is connected to property 1. And that means because property 2 and property 3 are also connected to P, that guess what? Property 2 and property 3 should both have value A, which means we can make predictions about what these things should be even if we've never seen examples of them in our actual input, which is, again, the power of this kind of over hypothesis, kind of generalization. So something to keep in mind considering the different types of evidence that we've talked about that kids can use. Property 1 has served as indirect positive evidence for properties 2 and 3. That is, it's indirect because it's not certain about property 2. It's not like you saw directly examples of property 2 and property 3. No, what you did was you developed an expectation based on property 1's connection to P and P's connections to properties 2 and 3. That's what makes it indirect. But it's positive evidence because it's like what you expect to occur. You expect property 2 and property 3 to occur with value A because of property 1 occurring with value A. That is, data about property 1 appearing in the input have allowed you to infer things about properties 2 and property 3. And so this highlights another benefit, is we don't have to learn the behavior of each structure individually. We just have to learn about that parameter that's connected to all of them. We observe some properties, maybe 1, and we can infer the behavior for the remaining properties, like 2 and 3 in this example. And that is instead of having to make 3 decisions, 1 for each property, You actually only need to make one. Is P, which connects to all of them, is P A or B? Once we know that, we know everything, right? That's the power of parameters from the perspective of acquisition. So the intake of the child is used to make this one decision, which generates useful predictions for a variety of other properties of the language.